we were in the module called statistics, and in the previous session, we were discussing about the various distributions. I hope you have received the material and you could get time to go through whatever we had discussed so far. So, in the last session, we were discussing about the normal distribution towards the end of that session. Previous to that, we had also discussed about other distributions, and we could solve a few of the problems. All right, now let's have a quick recap of the normal distribution, because today our major discussion will be on the normal distribution itself. Okay, so as you can see, the normal distribution has a specific equation given in the format f of x, right, which calculates the probability density function, okay, of any variable that follows the normal distribution. Okay, so this equation we are very familiar with. The class before the previous class, we actually had written a code to implement that in Python and to visualize a variable, okay, a particular random variable which follows the normal distribution. Right. So the PDF is given by the equation f of x equal to 1 divided by root of 2 pi sigma square into e to the power exponential of minus of x minus mu whole square by 2 sigma square. So what are the various parameters that decide the shape of the curve? The first one is a mean of the variable, that is denoted by mu, and the variance sigma square, right, or the standard deviation. That you can consider one of them because the variance is the square of the standard deviation. All right, so this is what we had considered, and the general representation in the form of a graph, whatever you see over here. Okay, so that is the plot of the function, right? We actually had seen, right, the visualization of this graph already we have seen, right, using the matplotlib seaborn we had plotted. Okay, so after that we considered that how do you convert this distribution into some standard format, because the normal issues associated with the normal distribution is that, right, it is present on the right side of the y-axis or the left side of the y-axis. It is centered around, not around the x equal to 0, but it is centered around x equal to its mean value mu. So the highest point whatever we get is around the mean of that particular variable, right? So because of that, right, we need to convert this into a standard format, and the standard format is what is called as the standard normal distribution. So we defined what do you mean by a standard normal distribution. It is a special case of the general normal distribution. I hope you are able to recall. Okay, and also the other feature of the standard normal distribution is that when I say I'm converting a normal distribution into the standard normal distribution, basically we are trying to, right, operate on the same set of variable, random variable, which is going to be moved to the left or right depending upon where it was originally located. For example, the previous graph, if you see, it is actually to the right side of the y-axis. Right? So because of that, now we need to move that to the left by certain, right, distance. So what is the expected value of the mean and the variance of a standard normal distribution compared to the normal distribution, right? You remember that the mean becomes equal to 0 and the sigma value, the standard deviation, is equal to 1, right? Whenever I have any distribution, any normal distribution, and I want to convert that into the standard normal distribution, that means, right, I have to convert whatever was the original mean, convert into 0, right, and whatever is the sigma value previously you had, convert that into the that is equal to 1. So now that makes it makes sense to say that the standard normal distribution is a normal distribution with mean equal to 0 and the sigma value equal to 1. This is the much easier way to define the standard normal distribution as a normal distribution. Okay, I hope you are all okay with this particular statement. This is very important, right? So we need to remember that when I say a normal distribution, we are referring to this itself, because any textbook or any reference you take, they call the normal distribution as a general distribution with the sigma and mu with these values. Okay, so I hope everything is clear. Now we'll go to the equation which we already have used for this conversion. So in order to, you see, make a note of this difference. See, the x-axis is not x anymore, it is z. X was the one which shifted, right? It was shifted over there, right? That had a x-axis value denoted by the x. Now I am calling the new variable, which actually is a shifted version of my original distribution, and I'm going to call this as the standard normal distribution, or in general normal distribution with the mu equal to 0, sigma equal to 2. So I have to convert the originally existing x values into the z values. So how do you do that? What's your procedure? It's very simple, right? I have to, x was there, mean was located at some point. I have to subtract the mean from that, so that mean comes to be, mean comes to the 0th position. So x minus mu, and I want to normalize the variance, normalize the standard deviation to be 1, right? So irrespective of your standard deviation, divide that by the original standard deviation sigma. So if you have a sigma standard deviation, dividing by the sigma gives you 1. Okay, so that's the whole idea, right? So important equation that everyone has to remember is this. How do you convert? Okay, that's the first thing. And the second point is that what if after conversion of x into z and doing some processing, doing some calculation, or doing all the manipulations I wanted to do, let me say I have done that. After that, if at all you want to go back, right? You want to go back from z to x, it should be possible, right? So for that reason, we use this equation, that is x equal to sigma times z plus mu. It's simple manipulation of my previous equation. Okay, so we do that and we'll get this, right? So this is how the conversion happens between x to z and z to x. Okay, standard meaning x is what, z is what, you already know. That's one thing which we have considered in the previous class towards the end of the session. Now, after that, we discussed about the equation, right? We have converted the general equation or the general normal equation into the standard one. So the standard one looks like this, right? This is a probability. So if at all you want to calculate the probability that, what is the chance, what is the probability that z lies between any of the two values on that axis? So you can see a diagram or a graph over here. This is nothing but we are trying to calculate the probability of that variable, that random variable, that lying between z1 and z2, right? So already it is a very well known fact that if you have a PDF, integrate the PDF to get the probability. So I am supposed to integrate this phi of x, phi of z now. So integration means what? The physical, literal meaning of integration of a curve means you are trying to find the area under the curve and the x-axis, right? So that means if at all I integrate between z1 and z2, I am trying to calculate this area which is marked in the red color, red colored region. That area is what we are trying to find out. This is also we have discussed earlier. I'm trying to make sure that you recall everything. Right, now if at all I want to calculate the probability, as per the basics, I should integrate this phi of z, right? So if at all you want to find out the probability for a specific region, put that as a limit. So just see here, probability is equal to integral z1 to z2, the function with respect to the variable of integration. So that is phi of z dz, right? Substitute, you have the phi of z already written, right? Just now in the above previous page we have written that, and right, so we are able to represent that in the form of an equation. Now let us look at some of the very peculiar features of this curve. right? This has a very peculiar features, right? Using which calculation of those probabilities become very easy for us. Okay, so that's one thing. Why we converted a particular graph which was present on the right side, why we brought it to the center, right? There is a reason for it. Now, the idea is that if you look at this phi of z curve, right, it acts the y-axis, that is, right, actually passes through the origin, right, divides your curve into two equal pieces, right, one on the left side, one on the right side. So that means this particular curve is said to be an even function. Even means you place a mirror, right, along your y-axis. Whatever is there on the right side, you see on the inside the mirror as well. So such curves are called as the even function, right? So that's a definition of even function. I'm going to use that definition slightly later. Let me come back to what I was trying to tell here. So the idea is that this is a probability density function. So there is one very specific feature of a PDF. So you have integration of any PDF. I'll write in general, so I'm not writing in the form of any equation. Okay. So integration of a PDF is always equal to 1. Okay, so maybe you know, you are already aware of this. Those who are not aware of this, just understand it's a probability. So adding each and every possible values of value of a probability function, the density function, should give you the value equal to 1. So integration is nothing but adding every point present on that continuous curve. So what do you expect? Addition of that should be 1. That's why the integration equal to 1. So previously when we discussed the discrete cases, maybe you are aware that if I add the probability of head is 1 point, probability of tail is another point, when you add you get 1, right? There we had only 2 points because the curve which we, or the function which we were discussing over there was discrete. But now it is not discrete, it is continuous. So continuous means I should add each and every point that is present on my curve, right? That results in the integration, right? So integration equal to 1 is my, the fundamental, from the fundamental knowledge of this PDF, we can say that this is equal to 1. That means if you integrate this whole function from minus infinity to plus infinity, you get equal to 1. But right, because the signal, the function which we are considering is symmetric about y-axis, the right hand side area should be 50%, same area should be present on the left hand side. So right, so because of that, 0 to infinity you integrate, that is equal to 0.5, minus infinity to 0, if you integrate you get 0.5. So that means this area, whatever I am marking now, that is equal to 0.5. all right. So at the same time, whatever I will integrate on the left hand side, that is also equal to this because of it being the mirror image of the other side. So this area is also 0.5. all right. So that's one very important feature that we are going to consider. Okay, that's one thing. Let's move ahead. Let's go to the second part. So because of the function being symmetric, I can use another property of what is called as the symmetric functions or even function. Now you see, let us say I want to find out this thing, minus z1 to plus z1, phi of z into dz. Let's say I want to calculate that. Now I know that I am supposed to calculate this whole area. Whatever I am marking with the red, the black color is the area I am trying to find out. Why? Because I am integrating the phi of z. Between any two values means you try to find out the area between those 2 points along x-axis and the curve. Okay, so because of that, now you see, is it necessary to calculate the whole thing integration? No, because calculate only one half, that is 0 to z1 you calculate, remaining one will be same as this, so simply multiply by 2. Okay, so that's what we are going to do now. So as you can see here, right, this part is equal to 2 times 0 to z1 phi of z dz, right? So that is another feature. Again, I'm not saying that you have to use this for each and every problem, but yes, right, this if necessary, definitely you can use, right? So that's the point that we need to understand whenever we say, okay, I'm solving certain problem using the normal distribution. Okay, then I actually mentioned about downloading a particular probability table called standard normal probability table. I hope it's ready with you. And right, those who missed the last class, please someone put the link of this table in the chat so that everyone can download that and keep it ready. Okay, so someone kindly put the link of the standard normal probability table in the chat, please. Okay, thank you, Gaurav, for the link. Everyone, please click on that link and keep a table ready with you. All right, so we will come back to this very soon. Then we looked at some other features, very important features of the standard normal curve. So now these were some of the questions I asked so that just to check your understandings of the whole concept. So my first question was minus infinity to infinity phi of z dz. That is the total area under the curve. Since it is a probability density function, area should be 1. Okay, so this can also be written in the following fashion, right? So that means what is the probability that the z is between minus infinity to plus infinity? It is a definite event, right? This is definitely going to happen. Z will be any value between minus infinity to plus infinity. So that value is equal to 1, which is the same meaning as my previous statement. This and this both are same, both are equal, right? This is the first point you need to remember, right? Then the next question I asked was, what is the integration minus infinity to 0 or 0 to infinity? I know that they are half of my previous case, so that will be equal to 50% or 0.5, right? So the same thing I can write it in probability notation, because integration of phi of x is a probability. So what is the probability that z is between minus infinity to 0? 50% chance, because that is the half of the area. Similarly, 0 to infinity is also half of the remaining area, so you will be getting an answer equal to, right, this. All right, then we actually had discussed a few more points. Let's quickly go through that. Probability z greater than 0 is half. Okay, so that is because z greater than 0 on the right side. So right side has a probability 50%, so that is half. All right, then z less than z1, right? What is the chance that, right? I want to calculate the probability that the z is lesser than a z1 and z1 is positive. Z1 is positive in the sense you will mark that point on the right side. Okay, let me just demonstrate that, because some of you might have something to confuse over there. Say this is the z1, right? And I'm asking what is the probability that z lies before this. Just the point to remember is that this whole area is considered, in the sense minus infinity till 0 is considered. That means what? It is 0.5. 50% chance is there. 50% plus this part, whatever is there between 0 to z1 is the only part which you need to calculate. Okay, so that's the ultimate idea. Everyone should be able to capture. Okay, so once you are fine with this concept, right, the understanding of the normal distribution and the solving various problems will become easy. So you see, this is the answer, 0.5, that's the left side, plus 0 to z1 phi of z dz. Okay, similarly, I actually had asked another question. What is the chance probability that z is greater than z2, right? So if you remember, right, how do you calculate this? Z is greater than z2 means we will mark a z2 on the positive axis somewhere here. Say this is z2. I want the right side. So totally the right side is what? Total right side is 50%, 0.5. So 0.5, you can subtract 0 to z2 from 0.5 instead of calculating from z2 to infinity. That's the right answer. I'm not saying that no, you cannot do. Yes, I cannot say that. You can do that. You can integrate z2 to infinity, right? Z2 to infinity, you can calculate. That's the answer. But I can calculate easily. Why I'm saying easily? Because we are going to use a table. right? So we are not going to do the actual integration at any cost when for any problem under the normal distribution case. Okay, so just to get adjusted to that, so I'm saying easy in that sense because my table is going to give me 0 to z2 easily than z2 to infinity. Only that's my point. Okay, so considering that, right, now I'm trying to write this as my equation. Okay, so z2 means I should subtract 0 to z2 from what? 0 to z2 I should be subtracting from 0.5. Okay, so till here we actually have discussed in the previous session. So any doubt with respect to these topics, please feel free to ask. Okay, I'll clear your doubts and I'll proceed further. Yeah, we are open for questions. Okay, that's good. So let's do something. Okay, let's start solving the very basic problems initially, right? We'll use all these concepts which we have discussed so far so that we can proceed further. Okay, so let's do one thing. All right, fine. This is the question. We need the table, so keep the tables ready. All right, so my first question is that, right, the area, I want to find the area under the phi of z curve. Okay, phi of z curve between z is equal to 0 and z is equal to 1.55. So this is the question. Now it should make sense what I am asking. Okay, so I am asking, right, let's say we have, this is the z, this is the phi of z, something like this, right? So I am saying that we have 2 points. One is 0, one is 1.55. What is this area is what I am asking, right? Literally, if you want to do the calculation manually, then this is what I'm supposed to do, right? So I want to calculate that area means it should be integral 0 to 1.55 phi of z dz. But phi of z is not so straightforward, right? So you see, if you want to do this calculation manually, right, if somebody wants to attempt, please try to attempt that. I don't suggest, right, but still it is, right, what's that equation? It's 1 divided by root of 2 pi integral 0 to 1.55. It is e to the power minus of z square by 2 dz. This is what you have to solve. Okay, right. Anyway, mathematically, the physical meaning of this area under the phi of z between z equal to 0 to z equal to 1.55 means this. Solve this and get an answer. So this is what is asked. I'll keep that question mark as it is, right? People who are solving by themselves will compare that answer later. I'm not following this method to get that answer. It's tedious. You have to do a lot of integration over there. So what we are going to do is we have our table. So let me go back to the table which we have here, right? So 1.55 is the something which we want to calculate. So that actually, okay, I'll give the notation first so that it becomes easy for you to find out in the table. So what exactly they are asking here is you have to find the value. Phi table you have, the whole table what you have, I call it as a phi table. Phi of simply 1.55. Yeah, okay. So Gaurav asked, I don't know how to solve it manually. Yeah, you need to go back to the basics of integration and you need to solve. Okay, so look at the ways to do the various types of integration, then only you'll be able to solve that. Okay, so as of now, our discussion is not related to the various types of integration. So we are not going to discuss that. Again, that is not necessary. Okay, manual solution is not required. So I just told that if anybody wants to compare the answer by doing the manual, they can do it. Okay, it's not necessary, Gaurav. You don't have to solve this manually at all. I'll tell you the other method, direct answer. Okay, using the table. Every time we use the table. Okay, yes. Fine. So now our intention in this case, right, is to find out the value of phi of 1.55 from the table. Always remember, the table gives area, right, under the curve between 0 and somewhere. Always 0 is fixed. 0 to some z we will be able to calculate from the table I mentioned. Okay, I hope, right? I hope we are clear with that.
Sir, I have small doubt. So can you scroll up the screen for a second?
Yeah, just a second. Yeah, this is the one you are asking?
Yeah, so just a second.
Sure. No problem. Please take your time.
Fine, sir. Fine. Please go ahead.
Okay, so we have a table, right? I'll try to open the table as well for us so that everybody can see the table, right? So just hold on for a second. I'll share the table now. All right, so I hope everybody can see the table now, right? So now our intention is to calculate the area between 0 and 1.5. Okay, so this is what you're supposed to do. So when I look vertically, whenever I look vertically over here, right, this is the initial few points after the including the decimal and after decimal, like 1.55. If I want to find out what I can find out, the nearest value vertically is 1.5. Can you see that? That is here. The 1.5 trace out vertically then to this I should add 0.05 to reach the 1.5. You trace along the top horizontal column, right? When you move like that, I get the 0.05 to the already calculated point, that is 1.5. Okay, to that 1.5 you add this, right? In the sense you move that, you find out the value which you need to add 0.05 to 1.5 to get that. So whichever both the horizontal line and the vertical line you identified will meet at point, that is the value which we are supposed to find out. 0.4394 is the area under the standard normal curve between 0 and 1.5. Right? No need to do the integration. That's the usage of this what you call as the standard normal curve. Okay, anybody having doubt with this table, please feel free to ask. I can explain again if you require.
This table is up to 3.0, and what if we are having more value to calculate?
No, don't worry. It will never go beyond that because of some reasons. I'll come to that later. Why you don't have more than 3, I'll come to. Okay? Yes.
Okay.
So, as of now, we want to learn how to use the table for different values of Z. Yes, there will be a question saying that what if I get 5, right? I have answered. We'll come later. Okay? Fine.
Okay.
Yes. So, any doubt with the table and usage of table? Any other doubt? Okay, so let's move ahead, right? So now our intention is, okay, usage of table. Gaurav is asking again. I'll explain. Okay, let me say I want to find 1.55. I'll go to the other values as well. Right now, let's stick to 1.55 because I asked a question. It says only 1.5. Okay, so if you want to find the value of area under the curve between 0 to 1.55. Okay, so if you want to find that 1.55, right, starting from the whole number, you keep tracing what you can find out on the vertical axis of this. So that means this line I am talking about, the first column. You try to find out the closest one over there. For 1.55, the closest one is 1.5. Okay, I hope you are fine with 1.5. Why 1.5? It's because 1.55 is what I want. Along this vertical line, I have 1.5, which is the closest. To 1.5, I should add something to reach 1.55. What is that? You find out along the vertical. Sorry, the first row. It says 0.00, 02, 03 up to 0.9. Why only till 0.9? Because after 0.9 you get 1.6. 1.6 is already present in the vertical, the first column. So there is no meaning in adding the next number to that. So right now I want to find right where they both of them will meet. So you see this comes like this, and from the top it comes like this, right? So both of them will meet at this particular point, which reaches a number 0.4394. Okay, any other doubt, any doubt you have, please let me know. Right, okay, Swapnil says you may please send all sheets about standard normal. There is no all sheets, only one sheet already given link. Okay, all right. Right, so let's proceed. Let's go back to our notes and we'll discuss something more from there. Okay, so 5 of 1.55 we have. Now you see you can directly write your answer over there, and the answer is nothing but the value which you got from the table. How much is that? It's a 0.4394. Yeah, okay. Swapnil says it's not the sheet, it's the notes, right? Already shared. I guess you already have it, right? In the LMS. It's already been shared, right? Whatever is written so far, it's available in the LMS. Whatever we are writing today and tomorrow will come to you in the next update of the LMS. Okay, please refer that. You will get it. All right. So that was the first question, and I hope everybody is okay with that. So I will move on to my next question, right? So everybody, please try to solve this. Now you have understood what, right? What exactly we want to find out, right? So that means my next question is, I want you to find out the area between z equal to minus of 0.86 to z equal to 0. Okay, I'll give 1 minute time for everyone to think and solve. If you have an answer, please put it in the chat. Okay. So every problem, don't go for manual calculation, not at all suggested. No need to solve the integration. Okay, that integral you don't have to solve. Right. So how do you solve? You will directly go to the table and you will solve. Okay, so that's the method. Yes, Swapnil.
Sir, in a last example, I want to we want solve 1.55, but normal distribution is considered in only is equal to 1.
No.
So how
No.
can
I'll tell you. The 1 is not the value of z. 1 is the standard deviation. From the center,
okay?
there is a deviation of 1. That's all. Okay?
Okay.
That does not mean that your curve is not there after 1. Curve is there, right? Till minus infinity, starting from minus infinity, it is there till the plus infinity. Okay? You see the curve here, right? This curve is not just between minus 1 and plus 1. So that is just the standard deviation. I hope that is clear.
Okay, thanks.
All right. Okay. Right. So we have few answers coming up. Ruchi, Pratik, Gaurav saying that 0.305. Okay. Okay. Other answers. Swati, Devendra also saying the same answer. Okay. Right. I'll give 30 more seconds so that others can also make an attempt. Right. It's okay if you don't have an answer or something. Right. But make an attempt. Try to use the table. All right. So meanwhile, any other question I would like to answer? Okay, so let me make the graph ready so that I can explain something from the graph. Right, so this is the graph, this is the z, this y-axis is the phi of z, and we have a curve, maybe something like this, let's assume. Okay, and now the question is that what is the probability, in the sense what is the area under the curve between the 0 and minus of 0.86 by default, right? As soon as I see the question, I understand that the area, whatever they are asking here, right, is nothing but the phi of minus of 0.86, isn't it? Because previous problem, area between 0 to 1.55. I simply calculated phi of 1.55 because my curve, sorry, but the table gives any value between 0 to z. That z you need to find out in the table. Z is 1.55. I got the area 0 to 1.55. Similarly, now what you need to find? Area between 0 minus 0.86 to 0 means I am supposed to find out phi of minus 0.86 on the table. But as I know, as I see the table, it only has the positive values, correct? I can find 0.86 but no minus 0.86. What is the reason? The reason is that, you see, if at all I try to find out this area, right, 0 to 0.86, if you find out, is that area same as the minus 0.86 to 0? Because of the property, it's a symmetric one, right? Doesn't matter, you find 0 to 0.86 or minus 0.86 to 0, right? You see these two area, right, whatever we are considering, they are same, right? So because of that, you don't find any negative values in the whole table, only positive values there. If you want to find a negative, find its equivalent positive. That means you are supposed to find out only this part, 0 phi of 0.86 itself is what we are supposed to find. So let's go back to the table. Let's try to understand how to find out from there. I think most of the answers which you have given here are correct. 0.3051 is the correct answer. Okay, so let me go back. So just see here, right? My intention is to find 0.86. Minus 0.86 is not there. I am supposed to find plus positive value. So 0.8 here and 0.06 here. So that value, whenever, right, you want to find out, that value is 0.3051. Okay, I hope things are getting clear now, as and when we keep solving more and more concepts, more and more problems. Meanwhile, if you have any doubt, please ask. Yes,
Sir.
Somsekhar. Somesh Kumar, my mistake, sorry.
Yeah.
Somesh Kumar.
Sir, my doubt is कि sir 0.06 value. So which method you take it? I am not understand this
Okay.
particular.
Okay, no problem. I'll come back. I'll come back to that. Let me move back to the notes. I'll try to write that. Okay, so let's say,
Yes.
okay, so just see here. This is what is happening. So 0.86 is what I want to find. In the column, we just have 0.0, 0.1, 0.2. What is the closest one I have? It's 0.8 only. That's why 0.8.
Yes.
Then
Yes.
I want 0.86, out of which I found 0.8 already. What is remaining? 0.06, right?
Yes.
That 0.06 you trace on the first row of the table. Previous one was 1.55, out of which 1.5 I already considered in the first column. What is remaining?
Yes.
0.05. That's all. Pretty straightforward. Okay, apply
Okay.
this and you
Yes.
will be able to answer.
Yes. Yes.
Okay, I hope that
Okay.
is clear. Yes.
Yes, sir. Yes, sir.
Sure, sure. Any other doubt? Any other question? Any other question? All right. Next question. Everybody, please try to solve this. All right. This is the next level. All right. So find the area between z is equal to minus of 0.44 to z is equal to 1.76. Okay, you have 2 minutes time to calculation. If you have the answer, right, please put it in the chat. Okay. Okay, we have one answer from Devendra. It says 0.17. Let's see. Okay, Ruchi says it is 0.6308. All right, let's wait for a few more answers. Okay, so Devendra says it's 0.4608. Okay, everyone, please put your answer in the chat.
So can you please scroll up for a second?
Yeah, yes, Manish, 1 second. Enough? Or you want to still go?
So just a second.
Okay, all right.
So can you explain this for a second, sir? Actually, like if we have to find like for the value of minus 0.86, so we have to see the positive of it in the table, right?
Yes, you need to find the positive in the table because area on the left side is equal to area on the right side. The table gives only the area for the right side value. Okay, it is because left side is same as the right side, right? You want to find 0 to z, you simply find, right? You want to find 0 to minus z, you simply find 0 to z. That itself is the answer. So here, minus 0.86 is what has been asked, but you will find 0.86 from the table. That itself is the answer.
So because from table we can see that 0.8 it comes out to be, and then 0.06 it comes out to be 0.3051.
Yes, yes. Okay. I think I didn't write the answer here. I think that's the answer. 0.3051. That's correct.
So, so then what we are like we have done some calculations on the right side.
No, no,
0.86
no. No,
minus
no.
0.
Just
What is
neglect
that?
that. That I wrote answering someone's question. Okay. Don't worry. Neglect that. He asked that how do you get 0.06, right? How do you find out that? So 0.86 is my value. 0.8 I find here. Well, how much is
Got it.
remaining? 0.06
Got it.
remaining. How do you find out? You do this calculation. That's all. Okay.
Okay.
Neglect that.
So, okay, scroll down, sir, for a second.
Yes, sure. Okay, that's all we have. So whatever you see here is the next question. Okay,
so now again we will do the same thing like 1.75676 we will see in the table, and then again we will see we'll make positive of 0.44, and then we will add both. And
yes, I'll come to the answer. Okay, I'm giving time for everyone to solve. Right? You approach in your own way. Try to find out answer. We'll discuss. Okay, I'll discuss the answer and you compare with that. And then if you have any doubt, you ask. Okay, please take your time.
Okay.
Yeah. So after that, we have many other answers coming up. Out of which one answer is interesting. Devendra Kumar says, "Oh, this is 1777. How you get that?" Think that it is an area under the curve and you are discussing about the probability. If you look at the basics of probability, it cannot exceed 1, right? Every value you see before this, everybody's answer may be right, may be wrong. They are not crossing 1, right? So Devendra, please check, right? You cannot cross 1. That's a hint. All right. Okay, let's go to the answer now. So let me draw something just to make things clear, right? Let's draw the graph once again. So this is what is the curve, let's assume. So there is minus 0.44 here. And there is plus 1.76 here. Correct? Now I want which area I want. I'll mark with two different colors. One area is this. This I can find from the table. That is phi of 0.44. And I also have to find out another area that is starting from 0 till 1.76. That is also possible. Correct? Two areas I will get from the table. Okay, let me write the answer. Then we'll go to the table and then we'll write the answer. Okay, then we'll do the calculation. So what they have actually asked here is, right, it's if I try to write in terms of the probability, right, this is also notation, this notation is also important for us. So probability of minus of 0.44 lesser than the z value, lesser than, you can even write less than equal, it can even touch that. Okay, so that is equal to 1.76. This has to be calculated only in this method. First I can calculate. So there is no single method, single value on the table which gives you this complete area. Correct? That's the first point which everybody should understand. Once you are okay with that, divide the required region or required area into two pieces according to the color I have given here. So first one is a red colored one. What I do, I'll try to write with the same color so that when you read this document, you will understand. So I'll try to use the red color. Using the red color, I am calculating phi of 0.44 from the table. Okay, then plus another color is there. I'll use the same color. So using that, I'm calculating phi of 1.76 from the table. Go to the table, find out two values, write the values below this to get the total answer. So phi of 0.44, let's try to calculate. Okay, as you can see here, 0.44, I can see that 0.1700, right? So everybody, right? Anybody has doubt with this value, please ask a question. Otherwise, right, it's fine. So 0.1700 is the first phi value, phi of 0.44. Okay, so my first number is that. Then the second number I want to find out is 1.76. So 1.7 here and 1.76 is here, right? So that is how much? 4608. Right, these two values I hope everybody got. You just have to add both of them. So that is the z value corresponding to this given question. All right, okay, let me write that answer here. So how much we got? We have 0.1700 plus 0.4608. So the total area required is 0.6308. Okay, so we have, okay, many people have given that answer. That's good, right? You're understanding the concept, right? Others also, please take your time, no problem. It's not expected to give the answer in a single shot. Take your time, understand what we are supposed to solve, right? Then you will be able to reach that, okay? It's absolutely fine. Let's go to the next question. All right, so yeah, the next question, everybody please try to solve and give me the answer in the chat. Okay, so I want you to find the area under, okay, or I'll write area between, that should be area between z is equal to 0.57 and z is equal to 2.49. All right, everybody, please try to solve. You have 2 minutes. So understand, try to draw the graph. Initially, that is the procedure, right? Once we are, until and unless we become very familiar with what is the area that is being asked, right? It is better to draw something, maybe it's, even if it is a rough to sketch, that's fine, okay? So just draw that, understand what exactly is being asked, relate that to the table, understand what I get from the table out of the given question, and do the maths. Meanwhile, we are open for questions. Any questions you have, please feel free to ask.
Sir, we are calculating the probability from minus to plus value. So there is no required to give the minus value. Then whatever we will get the output.
we have to calculate the value for minus, okay, but those it's equivalent that you calculate on the positive side itself. You don't have to calculate the negative value from the table. That's what is the indicator. Okay,
Okay.
I want to calculate minus 0.86. No need to find out that, because 0.86 positive value in the table gives you the same answer that of the negative value.
So then no need to give the negative sign there.
To the answer, if it is required, you may have to put a minus, but so far we have never come to till that point. Okay, we'll come to that point with the answer being negative. We may have to make a subtraction in the middle, but so far what we have done, no subtraction. Okay, no negative sign so far, but after this problem maybe we have. Okay,
Okay.
right. So see, look at this answer. Once after that, till you have an answer, question means you ask me again, I'll explain. Okay. Okay, so we are getting some of the answers. All right, so starting from Devendra, 0.3298, Ruchi, 0.2779, Gaurav, 0.7039, Mona and Pratik saying 0.2779, Swapnil saying 0.7093. Okay, right. I'll give 30 seconds more so that whoever is about to finish their answer can give their answers in the chat. Okay. Okay, others, whoever is about to finish, please finish that quickly and put your answers in the chat. Okay, Priyankar says 0.2795. All right, we'll compare. Yes, Manish.
So can you scroll a little bit up?
Yes.
More up, sir. More up.
Still? Okay.
Sir, little down.
Down. Okay. So that means this question, right?
No. So the last one.
This is the last question we solved.
Yeah. So just please hold it.
Yeah, sure. No problem.
Now, sir, scroll down.
That's all?
The next question, sir, please.
No, only this is the next question. You see here, after that, I have not written anything. This is the next question I asked. Area between 0.57 to 2.49.
Okay, sir. Thank you.
Sure. Okay, so I think we have few more answers coming up. Okay, Swapnil 0.2779, Somesh 0.2796. Okay, I appreciate everybody's efforts. Let's look at the answer. Okay, so right, so this is the Z, this is phi of Z. Okay, some curve like this. Okay, now we are more concentrated on the right side. Let me say that this is the starting point, that is Z equal to 0.57. Okay, and the next part is this one, right? So let me assume that that is 2.49. Okay, it's positive, so not negative, 2.49. Now the question is to find out this area which is in the red color. Okay, but you see, if at all I calculate, right, this is the point. From the table, definitely I can calculate phi of 2.4. Correct? So let me write something so that those whoever feels this little bit tricky to understand, that becomes clear for them. Most of you have given the right answer. Okay, so absolutely fine with that. So others, whoever feels this difficult, I'm trying to answer, writing something. I'm trying to write something for them. So when I calculate, so one value that is phi of 2.49, that actually gives the area 0 to 2.49. I hope that is very straightforward and very clear. Again, what we do, we normally look at that, okay, there is a value 0.57, right? So that means I calculate phi of 0.57, if you look at that carefully, this gives 0 to, not 2, sorry, my mistake. It is a 0 to 0.57, right? Now you see, when I actually calculated the, okay, let me change a different color. When I calculated for 2.49, I already have this total area, right? The new color you look for. It actually takes care of 0 to 2.49. But I don't want, I want only from 0.57 till the now. That means what I am supposed to do, this area, whatever I am marking, right? Now I need to subtract from the total area, right? Right? That means, right? Phi of 2.49, that gives 0 to 2.49 minus this area. Okay, this area, right? This area I need to subtract. That means, what is the answer? Right? Many of you have doubt. I'll come back. Right? So the required answer is phi of 2.49 minus phi of 0.57. Okay, so let's go back to the table. Quickly look at the table and try to give me the value. All right. So the value of the first one, that is phi of 2.49. So 2.4 is not visible on my screen. Let me check that. Okay, where is the cursor? Okay, maybe 2.4 is visible. Then 9 will be the last value, right? So 0.4936. This is the value. Okay, I'll just highlight. 2.49 is this value, 0.4936. Finding the value from the table is not an issue for anyone now because it should be fine. Okay, so 0.4936. What is the other value? That is 0.57. Okay, let me quickly move slightly up. Okay. So when I go there, what's 0.57? 0.57 will be 2157. Okay, so that is this value, 0.2157. Okay, right. So that's fine with everyone, I guess. Now, let us go back to the notes. And now let me write those values, right? So that is the first value is how much? 0.4936. Subtract that, from that subtract 0.2157 gives you the most common answers which everybody has given, that is 0.2779. Anybody, any doubt? Please feel free to ask.
Sir, you may please scroll down whole example.
Once again, yes, definitely. Yeah. This one?
Okay, fine.
Let's move ahead. The next one, which I want to ask is, okay. Find the area to the right side of z is equal to minus of 1.96. Everybody please try. You have 2 minutes. Okay, anybody who's left who wants to give it the answer? Yeah, please give the answer. Meanwhile, I'll draw the graph required for this problem. We have curve like this. Okay, now you see the z value given is somewhere here. Maybe that is minus 1.96. So the question says find the area to the right side of this. Under the curve, right, to the right side of this, right? That means it's not only 0 to minus 1.96. Maybe few of you consider only this part. To the right side means it is complete right side till the infinity. The curve goes all the way to infinity, correct? Just right. Consider that. Few of you have done, you have not considered. I don't say it is wrong because you consider only from minus 1.96 to 0. Those whoever has considered only that part and now you want to update your answer, it's the time for updation. I give you 30 seconds of time for those who consider only 0 to minus 1.96. Okay, I hope what is the question now? Complete right side from minus 1.96 all the way till the plus infinity is what is the question. Okay, so we can see corrections now. Pratik updates answer to 0.9750. Okay, good. Okay, so the area required is nothing but, let's split this total area. I understand that minus 1.96 to all the way to infinity is what I want, right? So not 0 to infinity, right? It's from minus 1.96 till infinity is what we are asking, okay? So to the right side, area to the right side of this number, that's the question. It actually says that to infinity because this actually goes all the way to infinity. The curve is minus infinity to plus infinity. Okay, Mona? Right. Fine. Let's try to answer now. So I'll split this because from the table, I don't have any chance to calculate the value till infinity. I can calculate up to somewhere. So that means I can definitely calculate this portion of the area from the curve. Correct? So that is nothing but phi of 1.96. Okay, phi of 1.96 give me 0 to minus 1.96 that directly. But we already know something, right? We already know that what is the area of this region. Right side from 0 to infinity, it's a standard value, right? It is 50% of my total curve. Total curve is 1. So half of that, that's why it is 0.5. So your answer in this case should be very straightforward. Phi of 1.96, whatever value you get from the table, plus 0.5. So this 0.5 is the area from 0 to infinity. Okay, so I think phi of 1.96 is the answer which many of you gave first, right? So that is how much? 0.4750 plus 0.5. Okay, the 0.5 is added for that reason. I want to calculate the complete area on the right side. All right, so that means this is equal to yes. Now, let me just try to write something. Okay. So that is equal to 0.9750. Any doubt with this? Please feel free to ask if you have a question. Meanwhile, I'll write the next question. I want people to find the following now. I'll not ask areas now. I'll move one step ahead. I'm going to ask the probability directly. So I want you to find out the probability that the z is greater than or equal to 0.85. So far I was asking the area, but area means probability, right? So relate that and try to find out this answer, right? Find out the probability that z is more than 0.85. Okay, you have 2 minutes. Everyone, please try to solve. Okay, we have one answer from Devendra, 0.3023. Okay, we'll verify. Ruchi says 0.1977. Swapnil says the same thing. Okay, we'll verify. Try to draw that curve and understand what is being asked, right? Greater than something, less than something, right? Try to relate that to the graph, and from the graph you relate to the table, because whatever asked in the graph is not available in the table, or whatever, right, we think that we get from the table is not the one which is asked. Okay, so always that confusion will be there until we get adjusted. Okay, so yes, so after that we have answers coming from, I think, yeah, Swapnil over. Yeah, Pratik says one same answer. Mona also same thing. Yes. Priyankar says 0.6977. Gaurav saying 0.8023. Okay. All right. All right. That's good. Everybody is trying. That is what is important for me, rather than the right answer, wrong answer. That's fine for us. We'll ultimately we'll come to the right answer once we practice. Okay, others? Please put your answers in the chat. Those who are about to finish, I'll give 30 seconds to finish quickly and put the answers in the chat. Okay. Okay, Priyankar, Swapnil, Partha are saying 0.1977. Okay. All right. So let's draw, right? It says greater than something, greater than a single point. So that means if you have a curve like this and find out a 0.85 somewhere here, what is the chance that the z value is more than this, right? More than point. In a sense, I am supposed to find out this, isn't it? So if I try to find out 0.85, phi of 0.85 from the table, what you get the other way around. You are able to calculate this, right? 0 to 0.85 is what we are able to calculate. But I don't want. I want more than 0.85. For which you use the property. The total area here is 0.5. From the 0.5, subtract the value corresponds to 0.85. Whatever remains is your answer. Okay, so think in that way. So the required answer, I'll write here, 0.5 minus the phi of 0.85. So this has to be 0.5 minus what is the 0.85 from the table. Please people refer, and 0.3023, I guess. Okay, so subtraction gives you 0.1977. Okay, anybody? Any doubt with this? Please feel free to ask. Meanwhile, I'll write the next question so that others can start solving this.
So can you please scroll? Sir, can you please scroll this?
Yeah. Yes. Manish, I'll come back. Just give me 1 second. I'll write the next question. 1.64 less than or equal to z less than or equal to minus of 0.88. Yeah, everyone, please take this question and start solving, and then I'll move to answer Manish's question. Okay. Okay, probability minus 1.64 less than or equal to z less than or equal to minus 0.88. Yes, Manish. Manish, you can ask the question.
Sir, a little upstairs, sir. Can you?
No, this was the last problem, Manish. You want to go still beyond this problem?
Yes.
Previous to this? Okay.
Yes.
This one?
Yes.
Okay.
Thank you, sir.
All right. Yes, so we are getting some answers now. Good. Swapnil, Ruchi, Pratik, Priyankar, Mona, all answers are same, 0.1389. Okay, Somesh, close answer, 1388, that's fine. Others, please try to solve quickly. Right. So let's try to draw this. This is the Z, phi of Z, right? So we have the curve like this. So they are asking both are on the negative side. Let me say this is minus 0.88. Say this is minus of 1.64. So the area they are asking is between these two, right? So your approach should be same. You will not calculate on the left side, you will calculate on the right side. That's all. In the sense, area you calculate between plus 0.88 and plus 1.64. They are same. So your approach will be phi of 1.64 minus phi of 0.88. Why so? This is pretty simple to the previous problem. Whenever I calculate 1.64, I am calculating this total area, right? Between 0 and that. This total area is not required, right? I have to eliminate the area corresponding to the 0.88. That is nothing but this area. You see, this area is what I want to subtract, because if otherwise I am actually calculating 0 to minus 1.64. 0 onwards it's not required. Only 0.88 to that, but minus 0.88 to that is required. So, right, simply do this calculation. I think the answer comes same. Everybody has written 0.1389. Okay, right? Those who have not, those who didn't get this answer, please verify, apply the same procedure which we have done so far, and you will be able to get that. Okay, my next question, let's go a little bit faster, all right? So that post the break session, we'll go to the actual problem. We'll wind up with the finding simple probability things quickly, and right, we'll take a break, then we'll come back and then we'll solve the actual problems based on that. Okay, right. So we need to go a little bit faster. So my next question is, find out what is the probability of Z being lesser than or equal to minus of 2.43. This is the next question. Everybody, please try to answer. You have 2 minutes of time. Okay, 2 answers we have. Swapnil says 0.0075, Ruchi 0.9925. All right. Let's see. So Priyankar 0.0075, same with Pratik. All right, that's good. Others, please try. Mona says 0.0075. Okay, that's nice. Same answer by Swati. Good. Okay, Ruchi says 0.0075. All right. All right. So next answer, what we get from Partha is also same 0.0075. Swapnil says same answer. Okay, so Somesh says 0.2571. All right, let's verify. Whoever is about to finish, please finish within the next 30 seconds and put your answers in the chat. Okay. So the question asked here is, take this curve and what is the chance if I say this is minus of 2.43, the z is lesser than that, it means it is the left side. Okay, so we are talking about this particular area that is till minus infinity. So from minus infinity to till minus 2.43, what is the area is the question. What is the area? That itself is a probability. But anyway, there is no way you can find that from the table, because table gives 0 to that number, right? From the table, what I can calculate is this, the red colored one I can calculate, right? Phi of 2.43 gives me 0 to that number. But I want the other side, means from 0.5, this total is 0.5. From 0.5, subtract the red colored region which you obtain from the table, you get the remaining part. So your answer should be, right, 0.5. Sorry, I'll write it in this way. So that is 0.5 minus phi of 2.43. So that is 0.5 minus, when you look at the table and you obtain the value phi of 2.43, I think we get 0.4925. Okay, so that is the value. So you have 0.0075 as the required answer. Okay, so please understand this and right, try to correct your answer. Those who did not get to this point, right, please correct yourself. All right, so let me know if you have any doubt. Meanwhile, I'm going to ask another question. I want you to calculate the probability of magnitude of z lesser than or equal to 1.94. Okay, this is what I want you to find. Okay, so everyone, please try to solve this. Meanwhile, if anybody has doubt with the previous question, please feel free to answer. Okay, we have one answer from Swapnil, 0.9738. All right, we'll verify. Please, others, put your answers. 9738. So yes, there's a question from Gaurav saying, what do you mean by magnitude, right? In the sense, magnitude means it's neglecting the sign, right? If you say -3, magnitude of -3 is 3. Okay, so that's what is the meaning of magnitude, right? Even if you have a minus value, you don't consider that. right? Okay, so Swapnil says 0.9476. All right. Others, please try. So we have answer from Mona saying 0.9476 as well. Okay, verify that as well. Others, quickly try to put your answer. You have 30 seconds more. So let's try to draw this. All right. So phi of z. Now, anyway, it means that magnitude of z should be lesser than 1.94. Magnitude should be less than means even if it is negative or positive, it should be lesser than 1.96. Okay, yeah, mod of z is less than equal to a means it is minus a to plus a. So that means the question now becomes very simple. Those who understood the meaning of magnitude, what is the chance or what is the probability that z is between minus 1.94 to plus 1.94? Right? So they are asking, right, find out this total area. Okay, here's the question. So from the table, I can calculate 0 to 1.94, which means 0 to minus 1.94 remains the same, right? So that means simply multiply that by 2, right? So required area is, so probability that minus of 1.94 lesser than or equal to z less than or equal to 1.94 is the actual question. So this is equal to 2 times phi of 1.94. So that is 2 times what is phi of 1.94? I think 0.4738, correct? So multiplication gives you the answer. I think most of you have done that, right? So that's appreciated. 0.9476. Okay, I hope that is clear. Any doubt with this?
So can you scroll up for a second?
Yes, Manish. Yeah, Gaurav, that's right. Magnitude means you have to take minus of that value to the plus of that. Okay. Yes, Manish, this is what you are asking?
So more.
Still up?
Scroll
Okay.
up. Yes.
Up? Okay.
Up. Sir.
Still
More
up?
up, sir.
Okay.
Thank you, sir.
All right. Next question. If x is a normal RV, stand for random variable, with mean value 30 and the standard deviation 5, find the following. So part A of the question, probability that 26 lesser than or equal to x lesser than or equal to 40. This is the part A of the question. And part B of the question, find the probability that x is greater than or equal to 45. All right, so when you read the question, it should hint something to you, right? That what type of normal random variable it is. You should be able to decide something about that. That's the first point. Once you're able to decide that, definitely we can move ahead and we can, right, proceed. Okay, so I'll give maybe 1 minute for you to think. And yes, if you have an answer, please give me an oral answer now. How do you proceed further? Okay. Okay, anybody? First thing that you need to use is that we have to use a table, right? So in the sense, I need to find out some curve, and area under the curve is what we want to find. That's the first thing. Look at the table, right? It says that it is a area under the phi of z, where that z is a standard normal curve, right? Normal means it's a standard normal. That's what we are trying. So my question is that, what do you mean by standard normal, or in general, right? Normal means what? It has to have mean value 0 and standard deviation 1, right? So is that the case here? Just identify that. It says that there is a mean 30 and standard deviation 5. That's the point which should give you some hint that this is not the standard normal. Whatever they have given is a general normal curve. There is a mean associated with that. There is a standard deviation associated with that. So convert this x into the z. Then you are able to use the table. Okay, so that's the point, right? So let's try to do that, right? So anyway, I'll use the word standard normal, but understand that that's the one which we are calling as a general normal curve. Okay, so how do you convert this, right? The x value is equal to, all right, so how do you convert x value? X is equal to, what's that? Is it x? Sorry, z, right? My mistake. Sorry, I have x given, which is not a standard normal, it's a general normal, right? Convert this into the standard normal. So that means I have to get a z now. So z is equal to the x value minus its mean divided by the sigma. So look at the question, they already have mentioned the mean and the sigma value. So any x you need, you can take that x, subtract the sigma, mu, that is 30, divided by sigma is given as 5. So this is the equation I am supposed to use for each and every x value present in the given problem, so that you convert that into the z form. Okay, that's the first thing that should flash in my mind, that okay, the given problem is not the standard format. I need to convert. How do you convert? Use this. Okay, once let us say that I convert this somehow, and now my intention is that what is the value that I need to look in the table, because table have very limited value, maybe 0 to 3, 0 to 4, something, right? So I need to look at that now. How do I convert? How do I reach that? So for that, let me start with answering the part A of the question, right? So part A says probability that 26 lesser than or equal to x lesser than or equal to 40. This is in terms of x, right? Convert the x into z and write the equivalent on the other side. This is equivalent to probability of, so x equal to 26. When x equal to 26, what is the value of z I am supposed to calculate using this? So that is 26 minus 30 divided by 5, because x equal to 26, right? So this value is x equal to 26. Highest value of x is 40, correct? This is actually present on maybe on the right side of your y-axis. I need to bring it to the center, right? So I get some value on the left, some value on the right, possible. So do that. So when I do that calculation, right, I'm converting. I'm going simply going to substitute 26 in the above equation. 26 minus 30 by 5. All right, so I'll write that now. So probability of this is 26 minus 30 divided by 5 lesser than or equal to z. You see z is going to come into picture, right? 40 minus 30 divided by 5. So that means, what is its equivalent value? I'll write that. Just verify whether you are getting the similar answer. Okay, so this is probability of, it's a negative value, minus, I think we get 0.8 lesser than or equal to z, lesser than or equal to, I think 10 by 5 equal to 2. Okay, so that's how we convert x into z. Now this is very easy. We already have solved these kind of equation. What is the probability that z is minus 0.8 till plus 2? Yes, we know the answer. Yes, right? Please try to solve this. I think we already have one answer given by Ruchi, 0.1891. Let's verify. Okay, right. So please find this from the table. Okay, so from the graph, it should be very clear that one of the point given is towards the left side, that is minus 0.8, and another point given here is to the right side of this, right? So that is 2. So total area required is minus 0.8 to 2. You will split that into two regions, 0 to minus 0.8 and 0 to 2. So whatever you find out, right, will be of the following type, I guess, right? So first will be the phi value of 0.8 will be calculated from the table. To that you add the phi of 2, correct? So I think you will get 0.2881 from the table plus 0.4772, that gives you 0.7653. Okay, yes, most of you have given that answer, right? I appreciate. Please proceed further. Calculate the next part of the question, that is x greater than 45. Okay, so that is part B of the question. What is the probability that x is greater than or equal to 45? So you will do the same thing, right? So convert x into z by doing this. So probability that z is greater than or equal to 45 minus the mean value 30 divided by 5, right? So that means I'm supposed to calculate what is the probability that z is greater than or equal to, this is 15 by 5, 3. Once again, go back to the table, find out 3, right? And use it and calculate the z value greater than 3. Okay, so I think few of you already have given the answer for part B, right? Looks like, yeah, Ruchi says 0.0013. And yeah, I think that's the only answer we have. Yeah. Mona says 0.1013. Okay, let's see. Okay, we have few answers. Others, please try.
Excuse me, sir. Sir, please
Yes.
once explain part A.
Part A. Yes,
Yes,
sure.
sir.
Yes. So the conversion part you are fine, right? P of conversion from X to Z. I hope that is clear.
Yes, sir.
Okay.
Sir, why we have added this 5.8 plus 5.2?
Yes. I'll draw something and let me explain that with a graph. Okay, so this is what is a curve. All right. And one value which they are asking is here, that is minus of 0.8. And another value which is given here is the right side, that is equal to 2. So now you see the total area is required. Okay, this is the question. Now when I calculate phi of
Yes, sir.
right,
Yes, sir, I got
0.8,
it. Yes.
I get left side. 2
Yes,
will
sir.
give you the right side. So you are supposed to add. Is that okay?
Yes, sir.
All right. Okay, so going in the very similar fashion, I'll draw the graph maybe somewhere here. Okay, so this is what the curve looks like. And the z equal to 3 is on this side. Okay, and the z greater than 3 means this area is what they are asking. Right, so if I calculate something from the table, that gives me 0 to 3. Right, I want greater than 3 means I should subtract that from 0.5. Okay, so this is 0.5 minus phi of 3. All right, so that is 0.5 minus what is phi of 3? I think 0.4987 from the table. Right, so that gives you 0.0013. Okay, right, please try to understand, right, and solve this, right? So next question. It's a similar question. Please try to answer this. If x is normally distributed with mu equal to 12 and sigma equals to 4, find probability that that X is greater than or equal to 20 and probability that X is lesser than or equal to 20. Right? Both of them try to solve together and give me the answer, right? Mostly I will not solve this in class because everything is already solved. Unless and until we have some serious doubts about this, I will not solve this. Okay, so I expect everyone to solve and get the answer for this. Okay, many questions already we have solved similar to this. Just convert this X into Z, then simply use the table to get the answer. All right. Yeah, already we have one answer. Part A, 0.0228. Yes, others? I hope everybody is clear. I think all the answers we are getting here are right. Everybody is giving the same answer. First one has an answer 0.0228. That's correct. And the second one, part B, 0.9772. All right. So that even when you read this notes by yourself or you calculate at a later stage, you should be able to find this answer. So part A, that is probability of X being greater than or equal to 20, you get an answer that is equal to 0.0228, isn't it? Okay, then part B, probability X being lesser than equal to 20 is 0.9772. Okay, let's move ahead. Like next problem, right? This is the next level of problem. All right, so yeah, so this is the question.
Hello, sir. Please scroll down. Last exam.
Yes, sure. This one. Okay. All right.
Yes, fine, sir.
Sure. Let's proceed. So this is the next question.
So one small request, sir. So can you scroll up for a second, sir? Sorry to bother you.
No problem, Manish. This one?
Yeah, so from the beginning, sir, before this also.
Before this? Yeah,
Yes,
that
sir.
is starting from here. Yeah.
So after the break, we started from this one.
Yeah. This itself.
So little down, sir, little down.
Sure.
More down. Sir.
Okay. Till here we covered. That's all.
Right. Thank you.
Sure. Okay, so this is the next question. All right. Marks of 1,000 students in an examination follows the normal distribution with mean equal to 70 and the standard deviation being equal to say 5. Okay, find the number of students, right? See, we are not asking the probability. All right, so that's the difference. Find the number of students whose marks will be part A of the question is less than 65. Part B of the question, more than 75. Okay, part C of the question, between 65 and 75. Okay, so analyze and try to solve by yourself. I'll give you 2 minutes to think and start solving. Okay, ultimately the answer is in terms of numbers, right? Out of 1000, how many will be less than 75? How many will be more than 75? How many between 65 to 75? That's the question. But ultimately, you are going to do the calculation in the very similar fashion how we did earlier. We get a probability, convert that probability into numbers at a later stage. But calculation of probability still exists. All right, it's a normal distribution, right? Mean and the standard deviation is given, means you need to convert this into, right, the z. X is given, convert it to z and start solving that particular z first. Okay, later on we'll see how do we convert them into the numbers.
So one question I have, sir.
Yes, Manish.
So like, sir, in this case, like earlier we used to calculate from x only. Like now, why we are doing converting x into z? Like any specific reason behind that?
Yeah, so you see, the z is called as the standard norm, which is centered at z equal to 0 and right around your y-axis it is equally present. Okay, that's what is z. But what is given here is not z, it is x, because you see the mean is located at 70, not at 0. Mean is the point where you have the highest value coming. That is at 70, right? But what I want, the table which we are using, right, that is valid only if your z is equal to 0. Mean equal to 0, not z equal to 0. Sorry, I correct that. Only when you have mean mu value 0 and the sigma value equal to 1, that particular table which we were using so far, right, we can use that only under that, which means whatever is given here, I need to convert that into the z. Okay, so that's why we are converting the given problem which is in x to z and proceeding further using the table.
Sir, if mu is equal to 0 and sigma is equal to 1, so you are saying that is standard normal distribution, right?
Yes, correct.
So, sir, now again, like if you are saying mu is equal to 0 and z is equal, sigma is equal to 1, then like why we are doing converting into z? That I've not understood.
No,
why?
this problem is not in z. This is in x. I have to convert that. You see, mean is given. You read the question. Question says mean is 70. STD sigma equal to 5. Is mean 0? No. Is sigma standard deviation is 1? No. You have to convert. That's what is z. Okay. After conversion, you get the z. That is the standard norm. Right now, it is simple norm.
Okay.
Okay. The given problem is normal. No problem with that. But it is not standard normal. Only when you have standard normal, you can use the table.
Okay.
All right. Okay. Yeah, we have few answers coming up. Okay. So part A answer 841. Okay. 341. All right. So I think people give the number of students, right? Okay, fine. Now it can be greater than. Okay. Only when we are answering. Sorry. Only when we are answering the probability, there is a condition 0 to 1. But now we are answering in the out of 1000 students, how many will be less than 65 like that? So you can go beyond that. Any number less than 1000 is a valid answer. Okay. Yes. Please put your answers, everyone. That's good. Many of you are working out and we are getting some answers in the chat. I appreciate it. Proceed. Others, those who are still trying, right? Please proceed further, calculate and put your answers in the chat box. Maybe we'll give you another 30 seconds or 1 minute to put your answers. All right, so let's try to solve this. Right. Meanwhile, please keep posting your answers, right? Whenever you get an answer, okay, we'll verify that later. So there are 1,000 students. Number of students, right, is going to be used only to convert your final answer into the number. Because final answer, whenever you use a normal distribution and we'll do the calculation, we get a probability, right? So multiply by 1,000 to get the number. So that is the fundamental logic that we are going to use. So what has been given here is the, right, let's assume that X is our variable. X represents the number of students. Anyway, I'm going to write this just for your understanding purpose. You don't have to write all this, what I'm going to write now. So I'll just write, say, let X denote something, right? It's the marks of students, right? Again, this is, right, this has a specific characteristic mentioned in the question, says that with the mean value 70, standard deviation 5. But I don't want that. What I exactly want is the Z. So Z is equal to X minus the mean divided by sigma. Okay, so that means X minus, what is the mean value? 70. Okay, divided by sigma value is 5. This is the Z equation. Now we will be calculating, right, the terms one by one. First, we will be able to calculate lesser than 65, that part A, right? How many number of students will be having the marks less than 65? First, we need to calculate the probability. Okay, so this is part A. First, I am calculating probability that X is lesser than or equal to 65. Let's calculate that. That means that is equal to probability that this Z is less than equal to 65 minus 70 divided by 5. Okay, so that means I am supposed to find out probability that Z is lesser than or equal to 65 minus 70 is minus 5, minus 5 by 5 is minus 1. Right? So probability that Z is lesser than minus 1 is my question. So minus 1, let's quickly draw this. So there is the graph. Minus 1 is somewhere here. I am asking for the value lesser than minus 1. Right? Lesser than minus 1 means what? You will do, okay, the complete negative side and subtract the phi of 1 from that. So that is 0.5 minus phi of 1. I hope it is clear. So 0.5 minus, what is phi of 1? I think phi of 1 comes to be 0.3413. Okay, so that comes to be 0.1587. Few of you have given that answer, I guess. Okay, so this is the probability. This is not the answer, right? So now I'm trying to give the answer. So therefore, the number of students in this category, right? So students scoring lesser than or equal to 65, right? This is nothing but out of 1,000, you calculate 1,000 into 0.1587. So that is approximately 158.7. We are counting the students. It has to be a whole number. There is no half, no 0.25, no 0.7. So approximately 159 maybe. Right? A few of the answers, I just have seen that there were a few answers saying that 158, 159 as the answer. Okay, we will take that. All right, any doubt? Any doubt with this particular calculation? First, I'll clear the doubt, then we'll proceed further. No doubt? That's good. Let's proceed further. We'll try to calculate the part B. Okay, so part B says that we want to find out how many number of students are there whose marks more than 75. right? So first we are supposed to calculate P of X value. X is the marks, right? X represents the marks scored by a student, should be greater than or equal to 75. So means what? You are supposed to calculate probability that Z is greater than or equal to X minus the mean value 75 minus 70 divided by 5, right? So that means probability that Z is greater than or equal to 75 minus 70 is 5. 5 divided by 5 equal to 1. Greater than something is being asked, right? So if you look at the graph, right? If I say this is equal to 1, greater than 1 means this area, right? So that once again from the total of right side total right side area, that is 0.5, I'm supposed to subtract this. So that value becomes equal to 0.5 minus 5 of 1. Already we have calculated, right? The value comes to be 0.1587. Okay, approximately. This is also 159 students. All right, that's good. Then the part C. Part C says how many number of students score between them, right? So one option is that 1000 is the total, right? From that I can subtract 159 and 159. So that should be one approximate answer. Otherwise we can proceed with the same method, and that also should give you the approximately similar answer, because we are truncating the 0.7 into something, right? So there may be the sum may not come to be 1000 when you add all the three, but it's okay. Okay, the procedure is what we are actually interested in. So probability that 65 less than or equal to X less than or equal to 75 actually can be directly converted into the probability that -1 less than or equal to Z less than or equal to +1, from -1 to +1. So it is same as 2 times probability of 0 to 1, so that is phi of 1, correct? So that is 2 times how much we have? Phi of 1, 0.3413, correct? Right, so that means point maybe 6826. This is the probability. So the number of students should be 1000 into this number, 0.6826. So approximate that to 683. Okay, so some comes slightly more than what is expected, 1001 I guess, but that's just because of the truncation of the decimal points. All right, otherwise we will get the correct answer. So we have a question, why you are multiplying by 2? Okay, so that is just because you see we have this kind of curve, 0 to +1 and 0 to -1. That is something like 0 to 1 multiplied by 2, correct? So you see phi of 1 is only the right side value, right? I need even the negative side, -1 to 0, I need to add to that, right? So 2 times of that. That's why it is multiplied by 2. Okay, yes. So this is the next question. Lifetime of bulbs is normally distributed. Is normally distributed with average life of 2000 hours with the standard deviation of 60 hours. If 2500 bulbs are purchased, find the number of bulbs that are likely to last for part A of the question, more than 2100 hours. Okay, part B of the question, less than 1950 hours. Okay, and part C of the question, between 1900 and 2100 hours. Okay, very similar question. I want everybody to try.
So sorry, I'm interrupting. So can you please show the answer A, B, and C for the previous question for a second?
Yeah. Just hold on, right? Let people finish this. And then I'll go back. Okay, give me just 1 minute of time.
Sure, sure.
What is standard deviation is 60 or 50?
60. Sorry, 60. Standard deviation is 60 and the average is 2000.
Here mean will be taken as 2000 divided by 2500 number of bulbs, or it is mean is 2000 hours.
Yeah, mean is 2000 hours. Number of bulbs purchased is 2005. Okay.
Okay.
So can we go to the previous slide?
Yeah, just hold on. I think people are still writing. Just hold on. I'll go back. Okay. Yes, Manish. This is the answer to the part A. Okay. And
so can we go to the question for a second?
question? Yeah, sure.
Yeah.
Okay.
So now
this is answer to part A.
sir, scroll up, sir, for a second.
Yes. Full. You want the question again?
No, sir. Just a second.
Okay.
Yeah, sir. Down, please.
This is part B.
So part A, last.
Part A. Okay.
Yeah, last.
Yes.
No, part B, sir.
Okay. So this is part. Sorry, just a second. Yeah, this is part B.
Fine, sir. Part C.
Yes, this is part C.
Right, sir. Thank you.
Yes, sure. Yeah. So everyone try to solve this. I think we are getting some answers already. Okay, part A answers 119, 508, 121, 121. Okay, we are close to the answers. Yes, that's right. Proceed further. Okay, I'll give 1 more minute so that whoever is about to finish the problems can put the result in the chat box. So we can see we have varieties of answers coming up, right? For this. All right. right? I'll start solving, right? Meanwhile, if you get any others who are getting the answers, please put your answers in the chat box. Okay, so what is given, I'll quickly try to write. So they have given a mean value that is given as 2000. Okay, and the sigma value is given, it's 60 hours. Okay, fine. Now, after this, anyway, the lifetime of a bulb is the variable here. And since the mean and the sigma values are not 0 and 1 respectively, this has to be the x variable, right? So the x variable is nothing but it is taking care of the lifetime of a bulb. Again, it's a random variable following the normal distribution. Okay. So that means I need to convert this into the z using the similar equation. Z is equal to x minus mean divided by sigma. So substituting the given values, I can write it as x minus the mean value, that is 2000 divided by 60. Hope this is clear. Because of the given data, I will come to know that this is whatever is the given problem here that does not follow the standard normal. It's a simple general normal curve. Certain mu and certain sigma values are. So convert that into the z, right, is what is happening over here. Fine. Now we can start solving the problems one by one. So let me go to the part A. It says that what is the chance, what is the probability, sorry, how many bulbs are going to, out of 2500, I guess. So 2500 bulbs we purchased. How many number of bulbs will, I think the question is, okay, how many number of bulbs will last for more than 2100 hours? Mean is 2000. How many will go beyond the mean? Sorry, beyond 2100 is the question. So, right, first we'll calculate probability that the x being greater than or equal to 2100 is a question. So convert this into the z. All right, so how do you convert? This is probability that the z is greater than or equal to 2100 minus 2000 divided by 60. All right. So this is 100 divided by 60. So we can approximate that P of Z being greater than or equal to, I'll approximate to 1. It's a 66667. So I just get 2 decimal points to be considered for the table, right? So I'll convert them into 2 decimal and I'll write 1.67. So maybe you consider only 1.66. Fine, okay, closely we'll get the answers, right? Very close answers, right? So that means Z greater than 1.67 is what I need to consider, right? Z greater than 1.67 means what? This is how it looks like. 1.67 is somewhere here. Okay, I want this area greater than 1.67, whatever is there towards the right. So I don't get that value from the table. I get the other value, 0 to 1.67 I get. So that means I should subtract from 0.5. So that is 0.5 minus 5 value of 1.67. Hope this is fine. So use a table. 0.5 minus 5 of 1.67 is 0.4525. Right? So that gives you a value 0. I think 0, 4. This is 4. Okay, 0.0475. This is a probability. So the number of bulbs I need to find out. Therefore, the required number of bulbs satisfying this particular condition, I need to multiply by 2500. So 2500 into 0.0, how much? I guess 475. That's going to give you approximately 118.75. So approximate that 2119. Yes, Gaurav. Approximately similar answer you get. Okay, 1.66 is also fine. Okay, so slightly different answer you may get. Right, so this is the answer for part A of the question. And let's move ahead. Let's try to answer the part B question, right? So in part B, I'm supposed to find out first the probability that X being lesser than or equal to 1950. How many bulbs will last lesser than 1950? So that is X, convert that into Z. Okay, so probability that Z is less than or equal to what's the equation? 1950 minus 2000 divided by 60. So that means I'm supposed to find out the probability Z less than or equal to 195. That's a minus 50 by 60. So minus of maybe 5 by 6, I guess. So 5 by 6 can be written as Z less than or equal to 5 by 6 is approximately minus 0.83, I guess. Approximate value 82 something or 8 something close to this you get, you consider that. Okay, so now you see it's the other way around. So I have the graph like this. Say somewhere here I have minus of 0.83. It should be lesser than this, means I should consider the left side. So that means all the way from minus infinity till that. So minus infinity to till that value means, right, I don't get that from the table. I get only the value from 0 to 0.83. So you will subtract from 0.5. So that is equal to 0.5 minus the phi value of 0.83. Okay, so this is equal to 0.5 minus, I think this value comes to be 0.2967. Okay, so from the table I wrote this value. Now that comes to be 0.2033. Right, so that's the probability that a bulb lasts lesser than 1950 hours. But I want the total number of bulbs out of 2500. So therefore, I can write the number of bulbs will be 2500 into 0.2033. Right, so approximately I think you will get a number 508.12 or 2 something. So approximate that to simply 508. Okay, even if you get a number greater than 508.55, you convert into 509, fine, absolutely fine. Okay, no issues. I hope it is clear. Any doubt so far? Let's move further. So this is part C, right? And in case of part C, our intention is to find the probability that 1900 is less than X is less than, even you write equal to, doesn't matter, less than or equal to, absolutely fine, 2100. Okay, right, so convert everything into the Z now. So probability that, so my first number is 1900 minus 2000 divided by 60. Okay, less than, now this is Z, less than 2100 minus 2000 is the mean divided by 60. So both sides I have, left hand side is 100 negative minus 100 by 60. So okay, probability that minus 1.67 less than Z value less than, yeah, okay, so this is plus 1.67. Okay, so since both sides are same and we are using the symmetric curve, right? That's a normal curve. You can simply write 2 times the phi value of 1.67, right? I need an equal space, equal area on both sides. Okay. So this means it is equal to, right? We can simply write 2 times. What's the phi value of 1.67? I think 0.4525. Okay, so that comes to be 0.905. So calculate the number of bulbs. Should be 2500 into 0.905, right? Approximately 2263. Okay, 2262.55 or something we get, right? So approximated to this now.
Can you show little scroll up for the start of section's answer C? Yeah.
Only answer C? Okay.
Yeah.
Sure.
Answer B also, I just want to see once again.
Yes, sure. Yeah, part C over. Manish, you are done?
So little down.
Little
C.
down? Okay, it's done.
Little,
C is
little
done.
more down, sir.
More down or up?
That's it.
That's all? Okay, yes. Okay, yeah, just check the answer, Mona.
Okay, thank you.
Sure.
Sir,
Any
please,
doubt?
sir, roll down. Please show the answer by A, B, C.
Okay, I'll show the answers right away from the beginning. So this is the question. I guess you are okay with that question. So here, this is where the answer starts. Okay, we find the mu value, we know the sigma value, calculate, convert x into z, and apply the condition x greater than 2100. Okay, let me know if you have any doubt.
No, sir. Thanks.
It's okay, fine. Let's move ahead to part B. Okay, I hope it's very clear. Then this is the part C. Okay.
Okay, sir.
Yes, sure. Any other doubt? Anybody? Any doubt you have with this?
Excuse me, sir.
Yes, Ruchi.
So what is the significance of all these theoretical equations and analysis of distribution functions in our data science?
Yes, that's a good question. Whenever we get a data, okay, we collect data from various sources. Maybe if you are doing an experiment and you are collecting the data set from a sensor, that's also a valid data set. Okay, maybe you do an experiment, you build your hardware, you connect some sensors like temperature sensor, humidity, etc. You calculate that comes into your computer. That's a valid data set. Similarly, you may collect the data set from something like maybe the Google data store, which we had used in one of the previous session. Any data set you consider. Normally, we have our idea will be to process that data set and get an insight of that data. Okay, depending upon the type of data set or type of your problem, right? These data points are distributed in various techniques. So standard equations are given. Those are what we were looking at so far, right? It will be normally in general, sorry, not normally, normal, because normal is one of the technique, right? So I should not use the word normal. Generally, they are distributed one of these standard techniques. Okay. For example, the duration of a telephone call, it's observed by doing research only. We cannot prove that, okay, it follows so and so distribution. I cannot prove it. There is no mathematics to prove that. But examples I can tell you. The duration of a telephone call follows a particular distribution, exponential. Normally it is exponential. Okay, and so on, like that. Each particular category of the data set, right, will fall under a specific one of the distribution which we have seen. So the idea is that if you are not able to collect the entire data set, let me assume, okay, because of some reason, maybe normally data set collection takes a lot of effort, time, money, etc. Many things. It matters a lot. Okay, so whenever you don't have, maybe I may not have time possible. Okay, I couldn't collect the data for 2 days. I could collect only 10 hours. I got a partial data. Okay, and yes, Gaurav, I'll come to that. Right. So in such cases, what we can do, we can try to model that, because right, one of the many many distributions which we had considered, right, will be followed. Right, if you have some idea about, okay, this data set might follow this particular distribution, then that is good. Otherwise also we can do that. I'll come to that at the end of this answer. Okay, so what you can do, you can calculate a mean and you can calculate the variance. For example, if we assume that it is normal, otherwise you know that if it is Poissons, if it is a discrete case, you go for Poissons. You just need mean and a parameter k to decide that. Like that, using them, you can at least create the various points required which are missing from your data set. You can actually fill up. That is one fundamental idea behind using this.
It means for predictions.
Yes, you can predict. Prediction also. It's fundamentally, I would like to call it as a modeling. I am modeling my complete data set. Okay, I am missing something. I can do a model, right? For modeling of our data, right? Because machine learning, the upcoming phases will be, I have a data set. How do you teach the machine to classify that, right? Maybe I have data set corresponding to last 5 years of the stock market, let's assume, right? And I want to give that to a machine. I want to teach the machine to model that, right? And predict what's going to happen when the market opens up on Monday. Particular stock, say Tata Steel. What happens if? Will you be able to guess that? To do that, I need a model. For modeling, I need a parameters. I might have collected 5 years of data only, but maybe you require something more than that. In such cases, all such parameters like mean, variance, covariance, etc., plus the distribution of your data set, etc., will be used for doing a model. And going ahead, maybe you want to predict, you want to classify, anything you want, you can go ahead with that. So that's why the statistics takes a very important role in the initial phases like this. I hope I answered that question.
Thank you, sir.
Yes. Okay. So there is one part of the question that is actually, I'm supposed to answer that at a later stage. That's why I told I'll answer that. But anyway, since the question came again, I'll try to answer. So whenever you perform x minus mu by sigma, right? So there is a condition that will be the max. Always it is 33%. Whenever you perform x minus probability that x minus mu by sigma, if you calculate. We already have calculated that, right? X minus mu by sigma is actually, right? That is nothing but, that will be, right? Say 33%, let's say 33% of your data set will be present within the x minus mu by sigma value around your center. So that means it is considered as a sigma value. Whenever I say I have a deviation of 1 around my mean, so that means somewhere this much. So half here maybe, or like that. So you see that that will cover out of my entire data set, right, 33%. Okay, I can say 0.33 on the right side. Probability that x is less than, sorry, z is less than x minus mu by sigma, whatever is the value, it is how much? It is 33%. Again, this is from practice, from observation, this is a conclusion. Again, no mathematics to prove that. I cannot prove it by doing some mathematics here. By observation of various types of data sets which follow the normal distribution. Okay, this is the statement, right? We'll come to this once again later when we continue where we left the earlier problem. There was a problem called, I think, what was the problem we were discussing when we discussed, poll, right? There were two people and we are trying to do a poll, and we actually left something from the middle saying that I needed these concepts before I go jump over there, because there is some mathematics coming over there. There I will be able to justify this answer. Okay, but let me continue the answer. Which means if you do probability of the same calculation, x minus mu divided by 2 sigma, right? It has to be 66%, twice the sigma rate. Already sigma was 33%. Consider 2 sigma. You are covering how much? You are covering 66% of all the data points, right? So which means, right, I can actually move the 2 to the other side now, which was 0.33, it becomes 0.66, like 66%. Same thing, go beyond that, right? Make it 3 times, 3 sigma, sigma 33, another sigma, another 33, another sigma, another 33. So 99% out of your this curve, right? 99% of all the points come within 3 sigma. 3 sigma means that is 3, right? The value which we are looking for is 3. That means out of all the data set, 99% of the data is present within 3 value only, sigma value being equal. Correct? So 99% means the other 1% is negligible because it can occupy any value starting from 3 till infinity. So which one you prefer? Considering only 0 to 3 or 3 to infinity? Because you are just getting 1% after. For 1%, will you look for the point till infinity, or you will simply, you are okay with considering only 0 to 99%? Okay. So we prefer only that the 99% of the data which lies within the 3, right? So without using any equation, I try to answer the question. I hope it is clear. But anyway, if you still have doubt, we will be revisiting this concept at a later stage.